Well, first I'm gonna have a couple of announcements. The first one is just a reminder that we have a test today. That the test will start, you know, at the 12 p.m. today. Let's see, what time? Yeah, 12 noon, and end at midnight. So you have a 12-hour windows to start your test. So however, once you start your test, once you start to answer your first question, then you only have 2 hours to complete the test. So so let me actually emphasize this again. The test will be available from 12 p.m. to 12 midnight. So you have 12 hours from this noon to the end of this day. Okay, you have 12 hours window. However, you can start the test anytime between this time period. But however, once you start the test, the clock is gonna be tickering. So you only have 2 hours. So you have to finish the test within 2 hours. So I gave you 2 hours window to complete the test. But the timing is very flexible. It's between 12 noon to 12 midnight. Okay. So the test will cover pretty much all the material from chapter 1. So pretty much the module 1. So from chapter 1 to chapter 4 and some of the chapter 5. So most of the problem are basically the multiple choice problem. So I think if you have done everything all right, you should be okay with the format of the test. And it's very similar. It's just a multiple choice. But even though some of the multiple choice problem, you still need to read the Java code and figure out what's the output and what output should be displayed. So you still need to read the Java code. You still need to think how the code is going to work. Okay. Any questions?
Is the test going to be on everything we've covered so far? Like, is the test going to be on like everything that we've covered so far? Like all the chapters?
Okay. Yes. Everything we covered so far. Another question? Because I saw actually 2 people try to answer the question at the same time, but Noah, do you have a question?
Yeah, Ryan had already asked the question I was about to ask. Like, what is the test based off of?
Oh, okay. I'm not going to ask you to test anything that we haven't covered yet.
Okay.
Any other questions? And also the programming lab 2 has been posted on the Zybooks, so you can start to work on this now. It's actually mostly the lab 2 is actually for the problems in chapter 5. And also I apologize for the Friday's class. I did post on the announcement which was actually available on last Monday, but I actually see a couple of people still logged in, tried to attend the class last Friday, but I should actually send you the reminder, before the Friday. But yeah. Okay, so any other questions before we move forward? Let's see. Let's check the discussion to see any questions you might have. I think for some, you can check the discussion forum for any questions and the answers. I ask you, sometimes I ask you the group to post some of the questions you might have. One of the questions I think I saw and I replied was the why don't Java arrays? So if I see any question which is very interesting, then I'm probably going to actually work together in a class. So I'm going to answer this question in the class, so everyone else can see the question and also the answer. So why don't Java arrays have append functions or similar? Or in other words, why don't they have a set length? Okay, so I think for the first question, now Python has some kind of a method called append. So if you declare a list in the Python, then list for the Python list, you can use the append actually function to manipulate the Python list. But Java doesn't have similar. Java doesn't have a similar function. The reason for this is, as we mentioned earlier, that even in CS1, so Java is it's called a statically typed language. Okay, Python is not. Python is called a dynamically typed language. Now, what's the difference between these two? Now, for statically typed language, so before you actually use any variable, you have to declare the variable. Okay, so for example, if you actually want to use an array, you have to declare an array. During the declaration of this array variable, you have to clearly specify how many elements in this array, or the array length, or the array size. So that means in Java, if you declare an array, that array is statically declared. So that means the array size is fixed. Okay, so you cannot change the size. So that's the problem why we're going to probably talk about this later. How can we deal with an array which can be expanded or not? But technically, you cannot do this with Java, but you can actually use a workaround. So you can still declare an array of fixed size, but you have to choose the maximum size. And then you can use the actual array, which is a smaller size than this one. So then within the range, you can actually move back and forth to change the size. But this is not really flexible. Okay. So because of this, so the Python is flexible. So you can actually declare an initial array, and the array size is 4, and then you can actually expand the list to 5 to 6 element. But the Python, the Java doesn't have the luxury. So that's the reason why Java doesn't have any functions like append or anything like this. You cannot extend the size of an array. So I hope I answered the question clearly. Now the second one, why would two-dimensional array be better than normal array or variable? The answer is it's not always better. It's just in certain application, two-dimensional array is better than the others. But in certain other application, you really don't need to define a two-dimensional array. So it depends on the situation. Now, in my answer, I actually provide an example, of a good example for a two-dimensional array. Okay, like for example, I can declare an array called grade. When I declare a grade, now, so the grade is gonna involve two things. One is the student, the other one is the course, right? So so in that case, two-dimensional array gonna be actually serving better than one-dimensional array. Okay, so for example, if you say you define the grade, okay, so then you can declare the grade as a two-dimensional array. The first index you can actually represent the students. The second index, the first index is which is a column or a row, which is a row. You can actually define the student. You say student 0, 1, 2, 3, and the second index, which represent a column, you can represent the course, different courses. So then you can use two-dimensional array to represent which student has what grade for which course. So for example, student 0 has a grade 98 for course 3. So in that case, you can say grade 03 is 98, and grade 13 has 60. Grade 13 basically means student 1, course number 3. Now it's 60. So in that case, the two-dimensional array probably going to be very good, to represent the data like this. Okay. That's my answer to this. What's the other answer? What's the other questions? What is the difference between an array in Java and a list in Python? Oh, I think I answered the question in the class. So, yeah. Okay. Okay. So, any other questions before we just move forward? Okay, so let's okay. So last time we talked about the method, and so method actually is a good way to reuse the Java code. So if you can actually end up using the same code again and again, so you can implement this piece of code as a method. So then you can call this piece of code again and again. Okay, here's an example I want to actually show you. The example is to the take-home pay. Okay, we want to actually use the take-home pay. Okay. So we want to create a Java method called take-home income that takes annual gross salary amount as a double value. It then estimates how much you bring home bi-weekly after taxes and the deductions from your salary. Okay. Now, so we want to create a method. Okay. So the method is going to actually have an import value, which is annual salary. Okay. So your annual salary is going to be calculated as like $100,000. Okay. That's your annual salary for your job. Now, when you actually get the pay, most company going to pay you bi-weekly. So then also, when you actually get the paycheck, it's not really like your annual salary divided by 26. The reason why divided by 26 is because there's 52 weeks per year, 52 weeks per year. Okay, so if you actually pay, the salary is paid weekly based on weekly pay, then your annual salary is going to be divided by 52, but bi-weekly you need to divide by 26, which is half of 52. So you're going to calculate the biweekly gross income. So your annual salary divided by 26, that's your biweekly gross income. Okay. You're not, it's likely that you're not get that much because you have to pay a lot of other things, you know. 6.2% Social Security tax from your biweekly income. So you have to deduct 60.2% out of your biweekly income. Now, after this, you need to deduct 10% of your retirement money because no one's going to pay you the retirement. Okay, so your retirement has been saved from your income. So typically 10% is kind of average. You know, some people pay more, some people pay less, and sometimes the company going to match your payment. Okay, like a 401k or something like this. So this method going to make it simple. Just say 10% of retirement money. So if you actually bi-weekly income is 100, then you need to actually deduct like a $10, which is 10% to save as a retirement money. And then after this, the Uncle Sam going to take away 20% federal tax. Okay, that's the other part. So now after this, then you still need to subtract the $195 medical insurance. Okay, so after all these deduction, then you will get to your final net income, net bi-weekly income. Okay, so this is pretty straightforward. Okay, when you actually try to write the Python code and Java code, you need to define this function, a method first, and then you're gonna call this method to do the calculation. Okay, let's do this. Okay. Now I'm gonna split the windows into two parts. One part is the okay. The other part is the repair window. I also want to okay. So so what I do here in the repair.it, I create a class called take home pay. Okay, take home pay. And now, so here's the deal. If you use this actually online compiler, I think this is a very cool tool, and so you can actually compile things online, and you can save your files online. It's free. You can create a free account with 500 megabyte storage. Okay. So one actually good thing about the repair is you can actually, do this online, and you can also share with your other people. Now, one thing I want to tell about is that once you create a Java code for repair, by default, the file you're going to create is called main.java. So which is actually kind of strange and weird. I don't know why they always create like things like this, but in Java, if you actually create a class called take home pay, then this class has to be stored in a file called take home pay.java. So you have to make sure the class name and the file name are consistent. Okay. Now in REPL, it always created as a main.java. So but the good thing is that you can change the name by using the shell command. Okay. I hope you understand how to use the shell command. Or use the console. Either way, it's gonna work. Okay, what I can do is, so if I want to change the name of your actually, say, if I want to change the name of my class, take home pay, I'm gonna change my class called take home I changed to take home bi-weekly pay instead of take home pay. Okay. Now, then the file name is called take home pay. So I have to change the file name. How can I change the file name? You can do this. You can say move, use MB. That's standing for move. And then your take home pay.java will be changed to take home bi-weekly pay.java. Okay. You can actually do this. So once you've done this, then your name has been changed to take home bi-weekly pay.java. Okay, so you can do this. But however, the drawback for this is once you change the name of the file, you cannot use this run command because the run command only for you work for main. Okay, unless you change the actually script. But I don't want to do this. But however, you can still use the shell command. In Java, actually, you can use the command line compiler called Java C. Have you ever used the Java C? So it actually works well. So it's not like the graphic actually compiler, but Java C actually works well. I like it. So it's a command line compiler. So let's see. Here's the method I'm going to define for this take home bi-weekly pay. The method is called a take home income. Okay. Now it will take the parameter annual salary. So the annual salary is going to be the parameter that passed to the method. Okay. So then your annual salary will be, changed to bi-weekly gross income. Okay. So the bi-weekly gross income is your annual salary divided by 26.00. Okay. Because as I say, there are 52 weeks per year. So if you actually divide your annual income into bi-weekly income, you have to divide your annual income by 26, which is half of 52. Okay. So this is actually your bi-weekly gross income. Now, once you got the bi-weekly gross income, remember that's not the amount on your paycheck yet, because now the paying start to actually you're paying to start because they're gonna take away your money. Okay. So the first one is Social Security. Okay. So the Social Security is gonna be 60.2%. So your actually bi-weekly gross income will be subtracted by 60.2%. Okay. So that means 60.2 divided by 100. That's 6.2 divided by 100. That's the 6.2%. And times the biweekly gross income. That's the amount of money the federal government is going to take away from you. So that's your contribution to the Social Security. So now, what's the remaining? So the remaining is after the Social Security, after SS. It is your biweekly gross income subtract your contribution to the Social Security. That's the after SS money. Okay. That's the first step. Now, after they take away your first Social Security, and then you can actually save 10% for the retirement. Okay. So that means after SS, then you're going to multiply 10%, 10 divided by 100. So that's the Social Security contribution. So you can actually put this Social Security contribution and save somewhere. Okay. So then after this, it's called after retirement. It's the after Social Security minus your retirement contribution, which is 10%. That's the after retirement money. Okay. Now, next one, after the retirement money, the federal government will take away 20% out of it. Okay, 20% out of it. That's 0.20 times after retirement. That's your contribution of the Social Security. So after retirement minus 0.2 times after retirement. That's the after federal tax. Okay. And then after actually this, you need to subtract 195 for your insurance contribution. So you need to purchase your medical insurance. That's 195 every 2 weeks, bi-weekly. Okay. So then you got your bi-weekly net. That's your bi-weekly net income. That's the paycheck you're going to receive every 2 weeks. Every 2 weeks. And then you're going to return this as a function, okay, as this function take home. So your return value is also double, okay. So that's why when you actually have a return value, you are actually bi-weekly net income as a double. You put the double here. So that's your definition of the function call. And then your main method, okay, your main method is going to actually have a scanner, define a scanner, and you can double. So you have scan the import and assign to gross annual income, okay, in your main method. So your import value will be assigned to the gross annual income, and then your gross annual income will be used as the argument for the take-home income method. So then you're going to call the take-home method income take-home home income and with the gross income as an import. And then this method is going to return your bi-weekly net. And your return going to be assigned to the bi-weekly net, bi-weekly net income. So you need to declare two variables. One is gross annual income. The other one is after you make the function call, method call, and you return the bi-weekly net income. So you need to declare these two variables. And this is actually the argument for the method. And this is the return value. And then you print the return value. So your bi-weekly net income is this. Okay. Let's actually compile it. So you're going to use Java C. You're going to compile a file called take home bi-weekly pay dot Java enter. So this can actually compile the code. Now, if you use the list file, you're gonna see that this is your source code, take home biweekly.java, and this is actually your class, take home biweekly class. That's the object file. And then when you try to run this code, you're gonna say Java take home biweekly. Okay. So this is how you're gonna execute the code. When you hit the enter, you're gonna print, please enter your gross annual income. And then you can type your annual income, let's say 90,000. Okay. .00. 90,000.00. Not bad, right? Okay. So when you actually prompt, type your annual salary income, and this is going to be actually read by the MyScan, the scanner, and assigned to the gross annual income. So the gross annual income will receive the value 90,000.00. And 90,000.00 is going to be used as an argument in the function call take home income. So then when you call the take home income, and you're gonna pass the gross annual income as the argument, which is 90,000. You're gonna pass 90,000 to annual salary, so the annual salary is gonna be 90,000 when you actually execute the function. So this is 90,000. So then you're gonna declare some intermediate variable, the biweekly gross income after SS, after retirement, after federal tax, and eventually the biweekly net. So the biweekly gross income going to be annual salary, which is 90,000 divided by 26. That's your biweekly gross income. And then after the deduction of SS, you will get this. After deduction of retirement, after deduction of federal tax, and after deduction of the insurance payment, and then that's your biweekly net. Your biweekly net is then returned. So the returned value is going to be assigned to biweekly net income. So when you print the biweekly net income, that's going to be the returned value of the function call. Now let's take a look when I hit the enter. So your biweekly net income is 2,142.78 cents. What do you think? Is it good? Not bad, right? But there's a lot of deduction, Okay. Now, if you want to print each intermediate value, then you can actually see what's the income for the intermediate value. Let's say, okay, let me actually put in here. So your biweekly gross income is this. Let's see. Okay. Your I'm gonna say after the Oh. Let me just check what it looks like. First, why actually just do this twice? So biweekly gross income. Okay. Then after the social looks like when I do the copy paste, I actually accidentally copy paste the 2 lines. So after the Social Security, so let's say after SS, okay. So I don't know why. I'm actually totally messed up. Right now. And let's say what's the and then after the retirement, deduction, the after retirement. Okay. So after retirement, and then the after federal tax. So let's just compare, in between after federal, after the federal tax, deduction, tax. Okay. Now this biweekly net, I don't have to print inside the function because it's already printed as here. Okay. So let's actually put the change the line here. Okay. So now let's actually compile. Let me see. I need to compile it again. Okay. So it's a 90,000. So let's see. Your biweekly gross income is 3,461. Now that's your biweekly gross income. So which is just 90,000 divided by 26. That's a lot. 3,461. But after all this deduction, you only receive pretty much like 2/3 of it, right? 1/3 of this are basically paid either as a social security or tax or retirement. So after social security deduction, you still have 3,246. After retirement deduction, you have 2932, and the federal tax deduction is after federal tax deduction is 2337, and then after the that's after the insurance deduction, which is 195, and you got this. So it looks like the federal government actually took most of the money, the federal tax. Okay. Any questions on this? Okay. So the next thing we're going to talk about is the array parameters. Okay. So when you let me actually use the other. Okay. So so when you actually call a method, you can actually pass the argument for a method. Say when you say a function, when you actually make a function call, and then you can pass an integer variable, right? So let's say a public static void, and you call the function, you declare the function, and here's the body of the function. So then this is the parameters you need to pass. Okay. Now Java allows you to pass the parameters or pass the argument as either integer value or floating point or even string or even array. Okay. Now, however, when Java actually passed the array to a method, an array is passed to the method by passing the basically it's when you pass a variable, you actually pass the value. Okay. Now, when you pass array, it's actually pass the reference. Now, what's the difference between these two? Let me actually tell you what's the difference between these two. Okay. So let me actually show the okay. Okay. Now, suppose I have a function. Okay. In a class, I declare a function. So in a class, I declare a function. Say, okay, public static void a function. So when I pass an integer to the function, and then somewhere in the main method, in the main method, I call a function. Say, I declare integer y, and then I call a function y. Okay. So basically, when I call y, integer, and then I assign initialize the y to like a 10. Okay. So when I actually say y is an integer and the initial value is a 10, and then when I call function, then I'm gonna pass the 10 to y, and then basically the value of y is 10. When I call the function, and then I'm gonna actually switch to the function. okay, here, and then I'm going to pass the value 10 to x, okay, and then I start to execute the code here. Now, in that case, when I declare y is, reserved a place, and the value of y is 10. And when I define a function here for the argument, for the parameters x in the function, then this value of x is going to be reserved a temporary location called x, which is also an integer. Okay, when I actually call the function, the value 10, which is actually currently in y, will be copied to x. And then the value of x becomes 10. So then in every time, if I have x, I'm going to replace with value 10. So x is going to be the 10. So the value is going to be copied to it. Now, however, if I actually declare a function, and then I declare an array, okay? So x over here is an array, okay? So when I call I have to call x0 equals 0, x1 equals 2, or something like this. I have to call this because x is passed as an array, okay? Now, in the main method, so when I declare y as an array, or I just directly use this. I could declare array y as an array with initialized as x1, 2, 3. And then when I call function 1, and I replace y over here, okay? So then, function 1 will be called, and the variable actually, the argument y, which is an array here, will be actually passed to the array x here. Now, in this case, just keep that in mind. What's the difference? When I actually declare an array y is an array, okay? Array variable. So in Java, the Java can actually reserve a space, okay? Because y is declared an array, and initially there are actually 3 array elements. So Java can reserve a space, which is, which contains like 3 elements. This is actually going to be the index 0, index 1, index 2. And then the array variable y basically stores the reference to the array object. That's called array object. So the reference is basically the variable y actually stores the memory address of this object. Okay, memory address of this object. So it's basically pointed to this object. Okay. So when you actually refer y0, you actually refer to, it's 1. That's 1. y1, 2 is 2, and y actually 2 is 10. Then this is going to be 10. So when you use the index to refer each of the array elements, okay. Now, when you actually make the function call, and then call the function 1, and the function 1 is declared as function 1 at array x. So in this case, x is declared as an array. Now, when you actually call the function, and refer y to x. So basically, this is gonna copy. This basically gonna copy the reference of y to x. So that means if the reference stores the memory address of the object, so that's a reference of y, and the reference of y is copied to x. So that means x gonna contains the same reference as y. So this means x gonna point to the same object that y points to. Okay. Hope you actually know the difference. So that means when you actually use the array to define the array and pass the array in a function, you are not going to copy any array elements. You actually, the x, which is actually the array variable declared in the function as the parameters, this x, there will be no additional array object will be created. So both y and x gonna point to the same object. So this array object gonna be the same. Okay. Now to see this, let's actually take a look at the example. Okay, let's take a look at the example. Now, because when you pass the like an index integer, or you basically copy the value to the actually copy the value from actually y to x. But when you actually pass the the array, you basically copy the reference from y to x. So the x is going to point to the same object as y points to. Let's take a look at the example. Okay. Okay, so let's go back to the REPL again. Here's the example. Okay. I create a class called array reference. Okay. And this is the main method. Now, I create two methods. Okay. One method is I call it square number. I put a wrong because this is a wrong way of use the method. Okay. Now, square number wrong has the parameter called a number reference. Okay. Number reference is declared as a array. Okay, integer, array of integer. Okay. Now, inside this method square number wrong, I declare another array called my number. So now my number is array which has the same length of number array or number ref. Okay, so the number ref, whatever the length of the number ref, going to be the length of my number. Okay, so then I do the for loop. Okay, I do the for loop. I say index equals 0, index less than number ref. Okay, then increase the index. So my number, each of the variable number going to be equals the number num-ref index times the non-ref index. Okay. So what does this mean? So that means I can actually, so my number is the square of the corresponding non-ref, right? Okay. If the non-ref contains the couple of elements, 1, 2, 3, 4, then my number contains the square of it. 1, 2, 3, 4, then my number going to be 1, 4, 9, 16, right? It's a square of it. You see the point here? And then I do one thing. I think I'm smart. I'm very smart, but it's not. So I actually calculate my number, which is each element of my number is the square of the corresponding element of my number ref. Okay, so number ref times number ref. So it's a square. And then I actually copy my number, which is declared as array, to num ref. Okay. And then going back to the main method. Okay, going back to the main method. So I declare an integer called number. It's a 2, 8, 11, 5. Okay, so then I call, first I put a print statement and say, call a round method square num round. So then I call square num round and put a number here. Okay, so then I can actually print, once I actually call the square num and I print it out, after I call the square num round and I print the number, still print this, each of the element of the number. Now, what do you think the number going to be? Okay, and then I declare another one called the square num without round. And then in this case, I just passed actually num ref, just the same as above. Okay, it's the same as above. So the pass the same reference. However, in here, I just directly say num ref times num ref and assign to num ref. Okay. Now what happens? Now let me actually first run this code. So now then you can see what's going on here. So I'm gonna call a Java code an array reference .java. Compile this code, and then I run this code. Java array reference. Just watch. Okay. The first part, I say call a round method square num round. So after I call this function, and then I just try to actually, initial value of number is 2, 8, 11, 5, and I call this number 2, 11, 2, 8, 11, 5, and I still got 2, 8, 11, 5. Now the second case, I actually got a 4, 64, 121, 25. So which is each number is a square of the previous number, right? So that's a 2 square, that's 8 square, that's 11 square, that's not 5 square. Now why for both each of the function call the result is different? Why the result is different? Now let's take a look at this first example. Okay, the square num round. Why this is the case? Okay, now let me actually do this again by showing you the okay, let me actually show you the Okay. So in the first case, okay, so I apologize for the small screen. I want to show both. Now in the first case, so shit, that's not. So in the main method, I declare number. Okay, so number is 28115. So I declare an array called a number. So the number actually, so I create an object which contains 4 elements. Each element is an integer. So the first element is 2, 8, 11, 5. So the number is an array variable which contains the memory address. I don't know what is the memory address. That's the memory address of this first one. The memory address could be like 0123 851, whatever the number. So which is pointed to this memory address. Okay. So this point to this one. Okay. Okay. So when I call square number wrong, so pass the number. So then this is going to trigger the function call here. Trigger the function call. Now, this function call inside the function, square num wrong, they actually create another variable called my number. Okay. And also declare at this. So not my number actually point to this, right? Now, when you make a function call, square wrong, so you basically pass the argument num to num_ref. Okay. So the num_ref basically going to point to the same it's declared as an array variable, and it actually pointed to the same argument, same object that the number going to point to, because that's basically what these array reference call means. So basically, when you call the function array a square num_rom, we pass the array. So the num_ref going to point to the same object the number points to. Okay, so this is what it is. Num_ref point to the same object this point to. So in a function call, my number, see this one here in a function call. So in a function call, my number index equals number ref index square, right? Number ref index times number ref index. So this basically means, okay, so my number, first one, the index 0 gonna be the square of, it's a square of this, so this get a 4. It's a square of number ref 0, which is this one. Number ref 1, this is 8. Number ref 2 is 11. So the my number actually is a square of number ref, right? So it's actually 64, 121, and 25. Okay. And then at the end of the function call, it just says number ref equals my number. That means I copy my number ref. I copy my number to the value of my number to number ref. What does that mean? num ref equals my number. What does that mean? So that means the num ref will no longer point to the number. It's going to point to the same object that my number points to. So my num ref becomes this. So it's going to disconnect this one and then connect to this. So that means that copy basically means it's a reference copy. So that means number ref going to point to the same object that my number is pointed to. So number ref going to point to the same object that my number going to point to. So that means when I return the function call, then when a function is actually returned, everything created over here basically disappeared, because that's the scope of the my number is within the scope of the method square number run. So when the square number run is finished, the call is finished, my number will be disappear. So my number ref gonna also will point to the nowhere. So in this case, if you still try to print the number, okay, in the main function, so then if you still print the number in the main function, so this number going to be the same as 28115. But now look at the second case. Look at the second method. The second method does not use the local array, my number. It just actually passed my number ref, okay, and then I directly change the value. So my number ref index equals my number ref times my number ref. So in that case, now what's the difference here? So in the second case, so I did not define anything here. Oh, there's no actually my number. Okay. So this is actually the second. Okay. There's no my number. So when you actually pass the reference, so my number ref, which is actually passed, okay. So the number ref gonna point to the same object that number gonna point to when you make a function call. That's the same, no difference, right? When you actually make a function call, so when you call square number num, so then you actually trigger the square num, the function square num, and the function square num, the num will be passed to the num ref. So the num ref gonna point to the same object that the number gonna point to. Okay. So now inside this function, so the number ref index times number ref assigned to number ref. So that means, so the number ref, so number ref gonna be, so number ref index from 0, 1, 2, 3 assigned to number ref index times number ref index, right? So number ref index 0, so that means 2 times 2 assigned to number ref index. So 2 times 2 will be override the 2, so which is 4. 8, which is num ref 1 times number ref 1. You got actually, so num ref 1 is 8. Num ref 1 is 8. 8 times 8 is 64. And 64 assigned to number ref 1. So then this will be replaced by 64. And this will be replaced by 121. This will be replaced by 25. 5. So now num_ref1 point to actually 4, 64, 121, 25. And then when you actually print a number actually points to the same as number ref. So the number is also 4, 64. So now you're going to see the difference. Now you're going to see why, in this case, when you actually print a number, you're going to print out 4, 64, 121. It's just a little bit, it's not really that complicated, but just remember that when you actually make a function call and you actually, if you pass the array, you basically copy the reference. You don't copy the object. So the reference number will be copied. So once the reference number copied from number to num_ref, from number to num_ref, okay? You copy the reference of number to num_ref. You basically point the num_ref to the same object that the number points to. So num_ref contains the same memory address as number. Okay, so that's basically the reason why. If you do this, you will find out, if you actually declare anything local and then copy the local reference to num_ref, this will not be passed back to the main function because this is local. So once the function is gone, this local reference is all gone. So, but when you actually do this square number and you use the num_ref throughout, okay? Now, remember, num_ref actually point to the same object the number point to. When you change the num_ref, you also change the number, okay? When you change number ref, you also change the number. That's the difference, okay? That makes the major difference between the reference, pass-by reference, and the pass-by value, okay? Okay, I think that's pretty much all for today. So take a look at these method parameter. If you pass by array, if you pass the array parameter, then you pass by reference, not pass by value. Just keep that in mind. Okay. Well, so this part is not in the test, so just forget about it for now. But let's actually focus on the test 1. And then on Friday, we're gonna come back and continue to discuss this. We're gonna actually talk a little bit more examples, so you have a better understanding on what's the real meaning of pass by reference versus pass by value. Okay, I think that's pretty much all for today.
Thank you.
Thank you.
Thank you, Professor. See you on Friday.
Okay, good luck for your test.
Have a good one.
Goodbye.
Bye.